Hi guys, how are you? I hope everyone is good. Today we're gonna just dwell into grade 11's Euclidean geometry because I was informed that some of so you said didn't touch on it or rather finish it in grade 11, and now it's gonna affect your marks in grade 12 because you need the foundation of Euclidean geometry. This is very important as it carries a lot of marks um, in your final, also in your June exam. So today we're just gonna just go back to do a revision. Um, so we're gonna start with the lines, familiarizing myself with the lines before I go much deeper into it. So now, as you can see here, let me get my draw pencil. So you need to know and familiarize yourself with these lines, right? So now you can see that we have this line that is touching the circle outside here. This line is called a tangent because of it touches the line out of the circle. This is a touch from the word touch. I don't know if I'm correct, but touch, tangent. So this is the line outside the circle. Yeah, touches. And then we have a chord. A chord is a line that touches the circumference, the circle here, and then towards the other point of the on the circumference here. So this is the chord, right? And then here we have the arc. This is the arc here. So arc is made of it it works with the chord in a way, I can say that. So it makes it an arc. Even this one here is an arc because of subjected to this line, I can say. But this line is not an arc. This line is a diameter. This line is a diameter because it passes through the center. So now we have this line here, from here passing through the center of the circle to this circumference. This is called a diameter. This is called a diameter. And then we have lines from the center to the circumference. This line from here, center to the circumference, we call it a radius. This line. So which other line is the radius here? This is the radius. That's the radius, right? From the line from the center to the circumference is called a radius. So this is the radius. And what do you know about the radius of the circle? Now, this one also here, from here to here is a radius. From here to here is a radius. But all in all, this line from here, say to here, this is a diameter because of it from here to here. So they will tell you this is A and then this is B. They're going to tell you that this line is a diameter. However, maybe they put C here. So you must know that AC is a radius, BC is a radius. And then what do you know about the radius of the circle? The line, all the radius of the circle. Now you should know that this radius is equals to this radius is equals to this radius is equals to this radius. All the radius of the circle. If you have another radius here, is equal to all the radius. The length are equal. I hope I'm making myself clear. The sector and the second, they don't normally, but then you can see them. We'll just check the examples, right? Okay, let's continue then. This is theorem number 1, which states that you need to know this thing by heart. So say we're gonna teach you, or you can also look it into your textbook. So it states that the line segment joining the center. The line segment joining the center. Let me put my phone on silent. The line segment joining the center. So now let's draw the center. Let me take my pen. So now let's draw the center. So this is the center. But the line segment joining the center of the circle to the midpoint of the chord. Let's draw the chord. This is our chord. But the line from joining the center of the circle to the midpoint. Now let's say this is our midpoint of the chord. All right, midpoint. And then when you hear the word midpoint, you should know that it bisects into equal. It's midpoint. It means um, it means this line here should be equal to this line because of the midpoint, right? So now this line joining the center to midpoint of the chord is perpendicular. You are told that this line to the midpoint is perpendicular to the chord. Why? So now how we're going to say this is perpendicular? We're going to say, okay, this line should be, the angle here should be 90 and the angle here should be 90, right? So this is theorem number 1. And then let's use let's say here it's A, and then here it's B, and then C, and then midpoint, let's use M. So now it's gonna be like M1, angle M1 is equals to angle M, let's say here it's 1, it's 2 here, and then gonna have angle M2 is equals to 90 degrees. It's equals to 90 degrees. So this is angle M2, right? So this is how the theorem, and then you're gonna state a reason. I'll look for the reasons because of the department use specific reasons for these theorems. So now for theorem 1, they state the reason accordingly. You need to state it as it is, the reason, only the reason. You're focusing on the reason, but you know that the whole statement stays. The segment joining the center to the circle of the center of the circle perpendicular to the midpoint. However, so this is theorem number 1. And then you know that this angle is 90, this angle is 90. And again, when I'm including the converse theorem of this theorem number 1, it's gonna say the line from the center bisects the chord. So when it bisects, you know that BC, where's my pen? You know that BM, the line BM is equal to line MC because of the line from the center perpendicular to the midpoint of the chord. That's the theorem number 1. So you can use these two things based on this theorem number 1, right? I'll look for reasons, and then for here the reason can be AM is perpendicular to BC. This is the reason for these lines to be equal. This line here and this line here. Yes. And then we're gonna go to theorem number 3, which states that the angle at center times 2 angle at the circumference, or rather the angle subtended by the arc at the circumference equals to